Hello. Hi, hi. So it's almost 10 now. I have asked you all to join by 10. Few of you all have joined. Where are the others? Yes. Fine. Good. All of us are punctual today. So, shall we begin? I just freshened up and I came back. So, I did some chemistry, taught my brother physics, and now let us start studying, continuing. That time we finished xylem and phloem of the permanent tissues, right? So now let us continue and finish off this chapter. Um, so, guys, I'll start. Okay, I think we are done. So let's start without wasting any time. It's already 10, correct? 10. So so we finished xylem and phloem. So that part is completely fine. Now let us go to the tissue system. So let us 5 minutes. Let us revise faster. In xylem, what did we study? In xylem, gymnosperms lack vessels. I told you all to remember GV. So gymnosperms lack vessels, and in that the only living thing was xylem parenchyma. The rest all were non-living. Fibers, tracheids, and vessels all were non-living because they lacked protoplast. Only living was xylem parenchyma, which stores food. And we told also we spoke about the xylem fibers, which has obliterated central lumen. Okay, and next we spoke about protoxylem and metaxylem. In root, it is exarch protoxylem, and in stem, it is endarch protoxylem. I also gave you some tips and tricks to remember that. Okay, and we also spoke the vessels and tracheids. How I gave you the short trick to remember? Remember the diagram given here. Vessels and tracheids. Two diagrams are given. So those are the main water conducting system in angiosperms. Then in phloem, I gave you some tricks to remember. First of all the components. What are those components? Phloem, in phloem, sieve tubes, companion cells, phloem fibers, and phloem parenchyma. In that, I told you gymnosperms. We have to remember this exception. Gymnosperms lack sieve tubes and companion cells. Instead of sieve tubes, which one is present? Answer to yourself. Albuminous cells. And instead of companion cells, which is present, sieve cells is present. Okay, that one is fine. So next, we also spoke about the living and non-living components in phloem, which was the here in xylem only one was living, others all were non-living. In phloem, only one is non-living, rest all is living. So phloem fibers is non-living, it is dead. Rest all companion cells, sieve tubes, and phloem parenchyma are living. Clear? Any doubt until here? No. Then protoploem, metaploem we studied. So next, let us continue with tissue system. Open your NCRT if you all haven't opened yet, and if you all are not comfortable with this, reading, kindly mute or lower the volume, and you all can study by your own. So you all can study with me. It's kind of that is the motive behind this session. So yeah, let us start. The tissue system. We were discussing types of tissues based on types of cells present. Let us now consider how tissues vary depending on their locations in plant body. Their structure and function would also depend on the location. On the basis of their structure and location, there are three types of tissue system. One is epidermal, ground, and vascular. So their function depends on the location and their structure. That is important here. Their structure and function would also be dependent on their location. On the basis of their structure and location, there are three types of tissue system. One is based on their structure, another one is based on the location. Three types of tissue system. Which one is it? Epidermal tissue system, ground tissue system, vascular tissue system. Now let us study the epidermal tissue system. In epidermal tissue system, forms the outermost covering of the whole plant body, comprises epidermal cells, stomata, and the appendages, trichomes, and hairs. So, epidermis is usually the outermost covering part of the plant. It forms and it comprises epidermal cells, it comprises stomata, and epidermal appendages, trichomes, and hairs. The epidermis is the outermost layer of the plant body. It is made up of elongated, compactly arranged cells which forms a continuous layer. Epidermis. Simple, we don't need any further explanation for that. Epidermis is usually single layered, and epidermal cells are which kind of cells? Parenchymatous cells with small amount of cytoplasm lining the cell wall and a large vacuole. Because of the presence of the large vacuole, the cytoplasm is really low. So epidermal cells are parenchymatous cells with a small amount of cytoplasm lining the cell wall and a large vacuole. Outside the epidermis is often waxy thick layer called cuticle, which prevents loss of water. The function of cuticle is to prevent the loss of water. Cuticle is absent in roots. Simple. Cuticle is absent in roots. Stomata are the structures present in the epidermis of the leaves. Stomata, what is the function of stomata? It regulates the process of transpiration and gaseous exchange. Stomata regulates the function of transpiration and gaseous exchange. Each stoma is composed of two bean-shaped cells and they're known as guard cells, which encloses the stomatal pore. This is the stomatal pore. See the diagram. These are the guard cells which encloses the stomatal pore. The outer guard walls here, outer walls of the guard cell, which is away from the stomatal pore, they are thin, and the inner walls which is there no towards the stomatal pore, they're highly thickened. So this right, dumbbell shaped. In grasses, monocots, they are dumbbell shaped, that you must know, and in dicots it is kidney shaped. Simple, that is. So here the guard cells wall, you have to remember, one is outer wall and inner wall. Outer wall is thinner, but inner wall is thicker. So clear, guard cells, inner wall is thicker, outer wall is thinner. So the outer walls of guard cells, which is away from the stomatal pore, are thin, and the inner walls towards the stomatal pores, they are thick. Okay? So the guard cells possess chloroplasts and regulate opening and closing of the stomata. So what does this guard cells do? Opening and closing, regulation of the opening and closing of the stomata is done by the guard cells. And these guard cells, what do they contain? They contain chloroplast also. Sometimes a few epidermal cells in the vicinity of the guard cells. So wherever this guard cells is present, in the vicinity of the guard cells, surrounding of the guard cells, few epidermal cells are present, and the epidermal cells in the vicinity of the guard cells, they become specialized in their shape and size and are known as subsidiary cells. So these subsidiary cells are nothing but few epidermal cells in vicinity near to the guard cells. They become specialized in their function. They become specialized in their function and they form subsidiary cells. So now the stomatal apparatus is there here. The stomatal aperture and the guard cells and the surrounding subsidiary cells together, it is known as stomatal apparatus. So what I was telling here, guard cells dumbbell shaped in monocots, kidney shaped in dicots. Okay. Then the guard cells walls is important. Outer wall is thin, inner wall is thick. It also contains chloroplast and it regulates the opening and closing of the stomata. Guard cells. Okay. And few epidermal cells in the vicinity of the guard cells become specialized in their shape and size and are known as subsidiary cells. So the some of the where did we stop? Some of the few epidermal cells in the vicinity of the guard cells become specialized in their shape and size and are known as subsidiary cells. They are known as subsidiary cells. So, what is subsidiary cells? Few epidermal cells in the vicinity of the guard cells. They become specialized in their shape and size, and they are known as subsidiary cells. The stomatal aperture, guard cells, and the surrounding subsidiary cells are together called as stomatal apparatus. What does the stomatal apparatus consist? It consists of stomatal aperture, it consists of guard cells, and the surrounding subsidiary cells. Okay? Here, guard cells function is the regulation of the opening and closing of the stomata. Important. Now if you look at the diagram here, this diagram, I hope it's clear. Here you can see epidermal cells given there. Those are the epidermal cells in vicinity closer to the guard cells. They are known as subsidiary cells. And here guard cells containing chloroplast is also given, and stomatal apparatus or stomatal pore is given. So this guard cells, subsidiary cells, and the stomatal aperture is nothing but hole, is together known as stomatal apparatus. Okay. And see, bean shaped guard cells is given in the diagram there. Diagrammatic representation A, stomata with bean shaped guard cells. So bean shaped guard cell is in your case of dicots, and dumbbell shaped B, stomata with dumbbell shaped guard cell, that is monocots. Everything is important, every line. So now let us come to the epidermis. Now we are discussing about epidermal tissue system, right? So your stomata comes under epidermal tissue system only. The stomatal aperture or everything comes, stomatal apparatus, the entire system comes under the epidermal tissue system. Okay, remember that. Now the cells of the epidermis also bears number of hairs. The root hairs are unicellular elongations. Root hairs unicellular elongation, but your trichomes are multicellular. Root hairs cellular, trichomes multicellular. So the cells of epidermis bears a number of hairs. The root hairs are unicellular elongations of the epidermal cells and helps absorb water and minerals from the soil. On the stem, the epidermal hairs are called as trichomes. Trichomes are usually multicellular. Root hairs unicellular. Stem ka hairs multicellular, trichomes. Here unicellular this is a root hairs. They do not have any branches as such, but trichomes in shoot system are usually multicellular. They may be branched or unbranched and soft or stiff. They may even be secretory in function. Trichomes may even be secretory in function. Trichomes helps in preventing water loss due to transpiration. So what is a function of trichomes? It helps to prevent water loss due to transpiration. Epidermal tissue system. See, what and all we studied in epidermal tissue system. One is about stomatal apparatus. Okay? Another one is about root hairs, then stem hairs, that is our trichomes. Now next we are going to study ground tissue system. In ground tissue system, we have to study about the uh, all the tissues in the except your epidermis and the vascular tissue. That is ground tissue system. So if you see the cross section of stem and all of that, except the vascular bundles and all present below the endodermis, and except the epidermis, the between layer is known as the ground tissue system. Let us read that para. All tissues except epidermis and the vascular bundles constitute ground tissue. It consists of simple tissues such as parenchyma, collenchyma, and sclerenchyma. So the ground tissue is nothing but except epidermis and except the vascular bundles. It consists of simple tissues like parenchyma, collenchyma, and sclerenchyma. Parenchymatous cells are usually present in cortex, pericycle, pith, and medullary rays. You need not by heart this entire line because they are going to study each and every part properly. That time they'll mention there only pericycle, parenchymatous, and medullary rays, parenchymatous, all that. So just don't get worried in that line. In leaves, the ground tissue consists of thin-walled chloroplast containing cells and is called mesophyll. The ground tissue in the leaf is dash mesophyll. What does it contain? Chloroplast. The ground tissue consists of thin-walled chloroplast containing cells called mesophyll. So in the leaves, the ground tissue is composed of thin-walled chloroplast containing cells called mesophyll. Okay. Now this vascular tissue system. So see, epidermal tissue system, stomatal apparatus, and epidermal cells, root hairs and stem hairs, trichomes, all of that. And the ground tissue system is nothing but the epidermal tissue system, except that and the vascular bundles, they form the ground tissue system. Now we are going to study vascular tissue system. Okay. So the third tissue system is the vascular tissue system. We're going to study about it. The vascular tissue system consists of complex tissues, the phloem and xylem. Xylem and phloem together constitute vascular bundles. In dicotyledonous stems, cambium is present between the xylem and phloem in dicotyledonous stems. Okay, such vascular bundles are, because of the presence of the cambium, they possess the ability to form secondary xylem and secondary phloem tissues, hence are called as open vascular bundles. So, open vascular bundles are usually the vascular bundles consisting of cambium. So, the vascular bundles containing cambium are called as open vascular bundles because they produce the secondary xylem and phloem tissues. But in monocotyledons, these vascular bundles, they do not have cambium at all. So in vascular bundles, when there is no cambium for present, there is no secondary tissues is formed. Secondary xylem, secondary phloem is not formed. So such type are called closed type. Okay, and one is open vascular bundles, another one is closed vascular bundles. Open vascular bundle, cambium is present. Closed vascular bundles, cambium is not present. When xylem and phloem present within the vascular bundles are arranged in alternate manner are along the different radii is termed as radial, and it is present in roots. See, radial arrangement are for roots. So radial vascular bundles are present in roots. What are those? Is nothing but the vascular bundles inside that, within the vascular bundle, xylem and phloem within a vascular bundle arranged in alternate manner along different radii are called as radial type, and it is present in case of roots. Okay. Before that, I want to have written an easier method. Where is it? Mm, just somewhere here. So, radial type of vascular bundles is found in R for radial, R for roots. Okay. The xylem and phloem in the vascular bundles are arranged in alternate manner. Okay. That is radial. In different radii, radial roots. Conjoined type of vascular bundles, xylem and phloem jointly situated along same radius. Conjoined, jointly along the same radius. Conjoined type. In conjoined type of vascular bundles, xylem and phloem are jointed situated again along the same radius of vascular bundles. Such vascular bundles are found in stems and leaves. In roots, radial. Stems and leaves, conjoint. Conjoined vascular bundles usually have phloem located only on the outer side of the xylem. So in conjoint, what is happening? The xylem is present towards center and the phloem is presented on the outer side of the xylem. See, here various types of vascular bundles figure is given. A, radial. See, that is radial. Your xylem and the phloem are arranged on different radii but alternatively. If you see this one is xylem here, the darker one, darker brown. I'm not sure if it is visible. So the darker one, if that is the xylem here, next to it is phloem. It is arranged alternatively, but it is on the different radii. See, xylem is a little towards inside, and phloem is a little away, right? So different radii, but arranged alternatively. After xylem, you find phloem only, and xylem again, phloem, but different radii. That is radial. R for radial, found in roots. Another thing is conjoint. Conjoint, xylem is towards and outside xylem you find phloem. B, conjoint, closed. What is the meaning of closed? I told you that cambium is not present to form the secondary tissues. So closed, conjoint closed. Usually monocots it's seen. Another one is conjoint open. See, xylem is towards inside and phloem is towards outside. So conjoined open, cambium is present, the xylem is towards inside and phloem is towards outside. So conjoined open. Okay? And here I had written that one statement which was easy to remember all these things. Give me 1 minute, let me find for that. Thank you. Um, quantity system. Never mind, wait. I will explain that during secondary growth. Now it is going to get confused. So here, another thing what we have to know is conjoint. Conjoint in dicot stem. Conjoint we have three types. One is collateral, bicollateral, and concentric. In collateral, xylem is inside. This is out of NCRT, but I just wrote it here on the NCRT while preparing last year. So let us revise. Xylem towards inside, phloem towards outside. Collateral. Bicollateral means bi. Xylem is sandwiched between phloem. So here phloem, here phloem. This pencil is xylem. Phloem, phloem. Xylem is sandwiched between phloem and phloem. That is bicollateral, as well as outer cambium and inner cambium. Okay? So in conjoint, there is collateral, bicollateral, concentric. Concentric is nothing but xylem and phloem surround each other. So if this is xylem, phloem surround around it, or if this is phloem, xylem surround around it. So if xylem is towards inside and phloem is towards outside, it is called amphicribal. Of concentric vascular bundles only, amphicribal. Amphivasal is phloem center, xylem surrounding it. That is amphivasal. This amphicribal, xylem center, phloem surrounding it. Concentric vascular bundles are of two types: amphicribal, amphivalsal. Amphicribal, xylem center, phloem surrounding it. Example: rhizome, ferns. Amphivasal, phloem center, xylem surrounding it, certain monocots, and other examples for that. Okay, Acarus, Acarus, Acarus example I've written. So conjoined, three types. One is collateral, bicollateral, and concentric. In this concentric, there is two types: amphicribal, amphivasal. Okay, so in conjoined, in that we have first one type is collateral. Collateral is nothing but xylem towards inside, phloem towards outside. Collateral. Bicollateral is nothing but xylem sandwiched between phloem and well as outer cambium and inner cambium. Concentric vascular is two types. One is amphicribal, amphibrazil. Concentric is nothing but either xylem or phloem surround each other. Amphicribal, xylem center, phloem surrounds it. Example, rhizome ferns. Amphivasal, phloem center, xylem surrounds it. Example, certain monocots and acarus I've written here. Okay, so the vascular tissue system is done. I hope there is no any confusion. That's all here. According to NCRT, we have to remember only so much. Radial is present in roots, and open vascular bundles are present in dicots and are absent in monocots, and in detail we'll study, okay, where what actually is present. Now, anatomy of dicotyledonous and monocotyledonous plants. So root and stem and leaves we have like this only, and then we have secondary growth. Okay, so dicotyledonous roots. Let us start. Mm, little notes. Leaf directly, no? Mm, okay, guys. Okay, ready? Dicotyledonous roots. Sunflower root. They have given there. TS of sunflower root. That means sunflower is a dicot. To transverse section of the sunflower root. Sunflower is an example for dicot. So, which of the following is dicot? Like five of it or four of it. If sunflower is given, include it under dicot. NCRT statement dicot is sunflower. Sometimes even I used to like confuse it with monogod sunflower, but sunflower is dicot anyways. So the outermost layer is called as epiblemma. In the root it is epiblemma, in stem it is epidermis. The outermost layer is called as epiblemma. Many of the cells of the epiblemma protrude in the form of unicellular root hairs. The cortex consists of several thin layered parenchymatous cells. So epiblemma is the epidermis, the outermost layer of the root, epiblemma, and they have unicellular root hairs. Root hairs are always unicellular. Epiblemma, unicellular root hairs. Now the cortex of the dicotyledonous roots. Example for dicotyledon is sunflower. Sunflower is a dicot. Fix this in your mind. Sunflower is a dicot. So the cortex have thin-walled parenchyma cells, and of course intercellular spaces are provided. And intercellular spaces, again, this in plant physiology will help us to understand apoplast and symplast and all. So yeah, leave it. So intercellular spaces are provided, and the innermost layer of the cortex is called endodermis. Refer this figure here on the right side. Epiblemma outermost, unicellular root hair. Cortex is made up of parenchyma cells. Intercellular spaces are present. The innermost layer of the cortex is called as endodermis, and it comprises of single layer barrel shaped cells without any intercellular spaces. Very important. The endodermis consists of barrel-shaped parenchymatous cells without any intercellular spaces, and the tangential walls and the radial walls of the endodermal cells have deposition of water impermeable waxy material suberin in the form of Casparian types. One is the radial wall and the tangential wall. So the tangential walls as well as the radial walls have of the endodermal cells have waxy material suberin. They are water impermeable waxy material suberin in the form of Casparian stripes. So the radial wall and tangential walls of the endodermis have water impermeable waxy material suberin called Casparian stripes in the form of Casparian stripes. Which walls of the endodermis? The radial and tangential walls. So remember TREC, 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 TREC. T R E C. C. T for tangential, R for radial, trek, T R E E for endodermis, C for Casparian strips. Tangential radial walls of endodermis have Casparian strip. They are nothing but waxy material suberin in the form of Casparian strip. Trek, T R E C instead of K, T R E C. Okay, next. Next to endodermis lies a few layers of thick-walled parenchymatous cells referred to as pericycle. So endodermis is there. Next to the endodermis, it is thick-walled parenchymatous cells referred to as pericycle. See, I told you in this page, pericycle, parenchymatous, pith parenchymatous, medullaris did not. Here only it is a pericycle, thick-walled parenchymatous cells. You will retain it in your so, parenchymatous, thick-walled parenchymatous cells referred to as pericycle. So, very important next line. Previous year questions. Last the previous year questions I used to refer last year for biology also. Many times this has repeated. Initiation of the lateral roots and vascular cambium during secondary growth takes place in pericycle. Initiation of the lateral roots and vascular cambium. Initiation of the lateral roots and vascular cambium takes place in the pericycle. The pith is small or inconspicuous in which of the following options? Dicotyledonous roots. Sunflower is an example for dicotyledon. Dicotyledonous roots. Pith is small or inconspicuous. Okay. The parenchymatous cells which lie between the xylem and phloem are called conjunctive tissues. So the parenchymatous cells which lies between the xylem and phloem are called conjunctive tissues. There are usually 2 to 4 xylem bundles and phloem patches. So there are usually 2 to 4 xylem and phloem patches. But in case of your monocot roots, no, there are many. Here, if you have seen, the yes, xylem, there are usually more than 6 polyarc condition in monocot roots, but in dicot roots, there are usually 2 to 4 xylem and phloem patches. So in dicot roots, 2 to 4 xylem and phloem patches. Later, a cambium ring develops between the xylem and phloem. All the tissues that is present on the inner side of the endodermis is such as what are the tissues present inside the endodermis? Let us recall pericycle, parenchymatous pericycle. Okay. Then vascular bundles, our xylem and phloem. How many xylem and phloem patches can be found in dicotyledonous roots? Only 2 to 4. In monocotyledonous roots, more than 6 polyarc condition. So all the tissues present on the inner side of the endodermis, such as pericycle, vascular bundles, and the pith, constitute the steel. It constitutes the steel. Okay, sorry. So, what is steel? All the tissues on the inner side of the endodermis, such as pericycle, vascular bundles, and pith, constitute the steel. Clear? Let us see the diagram. See, okay, if you all have attended my earlier live session in today's evening, you all must know this for sure. If you know this answer, that means this is being beneficial to you. Okay, so now tell me, In roots, which condition of the xylem is formed? And how did I tell you, make you all remember it? In roots, exarch or endarch? It is in roots. Am I audible to you all? In roots, what kind is formed? I gave you all a trick also to remember. Which trick is that? Yes, cow. The grazing technique. In roots, usually cow don't come and graze the roots. So what is happening there? The protoxylem need not be protected. It could be stayed away from, I mean, towards the periphery only. So it is exact. See the diagram. Root hair is present, epidermis is present, cortex is present, endodermis is present, pericycle is present, protoxylem is present, metaxylem is present, pith is given, pith is small or inconspicuous in dicotyledonous root, and phloem patches 2 to 4 xylem and phloem patches in dicotyledonous roots. Example sunflower. Now let us go to monocotyledonous root. Monocotyledonous root, example sugar cane. Please write down. Sugar cane is a monocot. Dicot is sunflower, monocot is sugar cane. The anatomy of monocot roots is similar to the dicot roots in many aspects. It has epidermis, cortex, endodermis, pericycle, vascular bundles, and pith. As compared to the dicot root, which have fewer xylem and phloem bundles, in monocots there are more than 6 xylem bundles in monocot root. These are called polyarch condition. More than 6 polyarch condition. Pith is large and well developed. Here, pith is large and well developed. In dicotyledonous roots, pith is small or inconspicuous. Xylem is 2 to 4. In monocots, more than 6 polyarch condition. Pith is large, well developed in monocots. Monocotyledonous roots do not undergo any secondary growth because of the absence of cambium. They do not undergo any secondary growth. See the diagram there, monocot example. I told you all to remember sugarcane. So this is the root hair, this is the epidermis, cortex, endodermis. एंडोडर्मिस के बाद क्या? पेरिसाइकिल, पेरिसाइकिल के बाद see protoxylem is towards the periphery, right? Metaxylem is towards the center. Exarch condition in roots. The cow example as Shema Hegde. Shema Hegde, correct. So it is exarch condition. Example cow. I made you all remember. Very good, Shema. Out of you all, at least she remembers. So here I want to vascular cambium. One question. I discussed this while studying NCRT also here. Vascular cambium during secondary growth is formed from which of the type of the cell? It is formed from pericycle. Okay? You know, teaching. I wonder how teachers teach now because constantly reading everything, especially every each and every line in CRT, drains your voice. I don't know how teachers teach in Akash, like from morning 8 till evening 8, God knows. And night, usually, we are all sleepy, right? Our eyes closed while studying. So, this is the better thing to do. Keep your volume high, study with me. How will you all sleep? Right? Yeah, it's 40 minutes. We were live for 40 minutes. Now we all can take a 5-minute break. Do not off the live and go somewhere because you'll never come back. I know that. So just keep the live on. Just maybe share it with your classmates or people who are doing self study. At least we all can be together in this, and hope we can complete the syllabus like this soon. So take a break for 5 minutes and come back. So this, yeah, Shema, let us start. Um, I would like to tell you all this one thing that I'm going to upload this live. So if you weren't present here during the live session but came across this video, this live session is going to be beneficial to you all. One, only subscribers of 5 minutes or longer can send the messages. So here only serious aspirants can join. Okay? There is not provision, there is not a chance for a person who's here to enjoy or chat with random strangers like this and here and there. That is not going to happen. I have changed the privacy settings. There is no spam, there is nothing like that, only studies, and I've also given gaps. A person can message only after 2 minutes or 3 minutes. So there is no kind of distraction at all in this kind of live session. Okay, so this is going to be really beneficial to you all. So I hope all of us make use of this beneficial live session instead of, you know, enjoying it as a leisure time or something. If you are not getting what I'm teaching here or trying to teach here, you all can mute yourself, the reduce the volume and keep the phone like this in front of you need not keep this in your high internet resolution. No, not expecting that. Keep it for 144p. Who cares? Lower internet resolution doesn't matter. But when you keep it there, you know that somebody you're competing with, a neat aspirant, or someone like you, is studying even this night. It is a sign that I should also study, right? So that way you all have to do it. So figure out, guys. There is time left. Do not think that it's all over. No, we all can do it. Like this way, we can complete one chapter of biology NCRT line by line. You try for one day sitting on by your own and read NCRT. See if you all can do it. I am sure because I've been through this phase, right? I've been through this phase and I know how it is. Every 5 minutes, 10 minutes, my mind deviates Go somewhere else. What if this would have happened? What if that would have happened? And start procrastinating, not studying instead. But when you're like this in life, you are studying because you know somebody else is studying. I hope this is understood by all. So I'm going to finish dicotyledonous stem and monocotyledonous stem. Dicotyledonous and monocotyledonous leaf, if possible, because I have to finish surface chemistry also. I didn't finish studying that. So tomorrow morning, guys, I'm going to write here. I'm talking this because it's break time now. Tomorrow morning, 7 a.m. live mute. No music. No music. No words. Okay. Tomorrow morning, 7 a.m. All of y'all ready? Yes. Ready? Tomorrow morning. The answer na. Yes. So only why Shima is answering. What are the others doing here? Hmm? Four people of you who's watching the live. Hmm? Okay, break up. Sorry, break is up, not break up. Break time is up. Okay. Monocotyledon's root is done. Dicot, remember sunflower. Monocot, remember sugarcane. Dicotyledonous stem. Transverse section of typical young dicotyledonous stem shows that epidermis is the outermost protective layer of the stem, covered with thin layer of cuticle. It may bear trichomes and few stomata. The cells arranged in multiple layers between epidermis and pericycle constitute the cortex. It consists of three subzones. The outer hypodermis consists of few layers of collenchymatous cells just below the epidermis, which provide mechanical strength to the young stem. Cortical layers below the hypodermis consist of rounded, thin-walled parenchymatous cells with conspicuous intercellular spaces. The innermost layer of cortex cells is called endodermis. The cells of endodermis are rich in starch grains and is also referred to as starch sheet. Starch sheet is a character of dicot stem. Endodermis layer are rich in starch grains and that layer is also called as starch sheet. Pericycle is present on the inner side of the endodermis and above the phloem. Inner side of the endodermis and above the phloem in the form of semilunar patches of sclerenchyma. In between vascular bundles, there are few layers of radially placed parenchymatous cells which constitute the medullary race. A large number of the vascular bundles are arranged in a ring. Ring arrangement is a characteristic feature of a dicot stem. Vascular bundles are scattered in your monocots. In dicots, it is ring type of arrangement. A large number of vascular bundles are arranged in the form of ring. The ring arrangement of the vascular bundles is a characteristic of the dicot stem. Each vascular bundle is conjoined stem. So dicot, conjoined, open or closed? Open, good. And with endarch or exarch. Remember the cow example again? Stem. It the protoxylem is small. It is baby. It will stem usually the cows come and graze. So protoxylem needs to be protected. It should be present inside towards the pith. Endarch. Protoxylem vascular bundle is conjoined. open and endark protoxylem. A large number of rounded parenchymatous cells with intercellular spaces occupy the central portion of the stem. It constitutes the pith. So again, let us read. The transverse section of the typical layer dicotyledonous stem shows that epidermis is the outermost protective layer of the stem. Covered with a thin layer of cuticle, it may bear trichomes and few stomata. The cells are arranged in multiple layers between the epidermis and pericycle constitute the cortex. Consists of three subzones. First is hypodermis, then few layer of colon chimeras cells is present just below the epidermis, which provides mechanical strength to the young stem. So hypodermis is a layer of colon chimeras cells present below the epidermis, and this hypodermis provides the mechanical strength to the young stem. And the cortical layers which is present below the hypodermis constitute round thin-walled parenchymatous cells with conspicuous spaces. Means the hypodermis is collenchymatous, right? It provides support to the young stem. Now, below the hypodermis, round, thin-walled, parenchymatous cells with conspicuous intercellular spaces is present. So, cortical layer, hypodermis, cortical layer, endodermis. So, the cells between the up till the pericycle, it is called as cortex, and this cortex is divided into hypodermis, cortical layer, and endodermis. Cortex hypodermis consists of few layers of collenchymatous cells just below epidermis, provide mechanical strength to young stem. Cortical layer is below hypodermis, consists of rounded thin-walled parenchymatous cells with conspicuous intercellular spaces. Now, the innermost layer of the cortex is called endodermis. The cells of the endodermis are rich in starch grain, and this layer is called as starch sheath layer. Okay, pericycle is present on the inner side of the endodermis. It is above phloem and in the form of semilunar patches. So, semilunar patches, it is present above phloem. So, what is happening? The pericycle is present on the inner side of the endodermis, but above phloem in the form of semilunar patches of sclerenchyma. See, semilunar S, semilunar S, sclerenchyma S. Semilunar patches of which tissue? Sclerenchyma. S, which is it is present where? Above phloem. I remember SAP. Semilunar patches. S for semilunar patches, sclerenchyma S. A for above, P phloem. So pericycle present on the inner side of endodermis and above phloem in the form of semilunar patches of sclerenchyma. What is the term I told you all to remember? SAP. S for semilunar, S for sclerenchyma, A for above, P for phloem. Okay. So how is the endodermis? The cells in the endodermis consist of starch grains, and that layer is called as starch sheet. Okay. So next, in between the vascular bundles, few layers of radially arranged parenchymatous cells which constitute medullary rays. So medullary rays is also made up of parenchyma now. A large number of vascular bundles are arranged in the form of ring. So, a ring arrangement of vascular bundles is a characteristic of which kind of stem? Dicot stem. The same thing in monocot is scattered. Scattered vascular bundles, monocots, ring arrangement of vascular bundles, characteristic feature of dicot stem. Each vascular bundle is conjoined. I explained you all that term. What is conjoined? Fast. Repeat to yourself. I don't want you all to comment here. I want this to be beneficial for you. Conjoined, xylem is towards inside, phloem is towards outside. Conjoined, open. Open means cambium is present. So it's a stem, dicot stem. So conjoined, open, and in stem, the previous live session, evening one live session, I told you stem. How to remember the protoxylem? Stem is present above the soil. It is going to be grazed by cow. Yes, Shema, you're right. Cow. So what is going to happen? Cow Cow is going to come and graze it. So protoxylem is baby, right? Protoxylem needs to be protected. So where are you going to place the protoxylem? Towards the periphery or towards the inside? Towards the inside. So protoxylem present towards inside in dark. So in case of the protoxylem, in case of dicotyledonous stem or any kind of stem, it is end dark, but dicotyledonous stem open, conjoined open and dark. Clear? I hope this is clear. I If this is not easy, I don't know what else is easy for you. So each vascular bundle is conjoined open and in dark protoxylem. A large number of rounded parenchymatous cells with large intercellular spaces occupy the stem, constitute the spith. So, again, parenchymatous, large intercellular spaces, rounded parenchymatous cells occupy the central portion of the stem, constitute the pith. Please underline the NCRT conjoined, open, and dark protoxylem, then starch sheath present, the left side of the page here, starch sheath present, underline that. And ring arrangement is a characteristic feature of dicotyledonous stem, underline that. And semilunar patches, how I told you to remember SAP, SAP. S for semilunar, S for sclerenchymatous, A for above, P for phloem. SAP. And here cortex, three divisions. Hypodermis, high code, HC. Remember high code, HC. I told you all. Hypodermis, oh shit, sorry. Hypodermis, HC, high code, C for collenchymatous, H for hypodermis, and then comes cortical layers below hypodermis, which is rounded parenchymatous cells, and then the innermost layer endodermis. And in this endodermis, the cells of endodermis, they have starch grains, and this layer is also referred to as starch sheet. Pericycle present in the inner side of the endodermis in the form of semilunar plexus, SAM, semilunar plexus, sclerenchyma, above phloem. Okay? I hope this is clear. Now let us go to monocotyledonous stem. In the monocotyledonous stem, we are going to study this new term called lysigenous cavity. Lysigenous cavity. Write down. It is not given in NCRT. Please write down. I had written while preparing for anxiety. See, this is what made me score. Not 305 is not a good score in biology. The paper was very easy. 355 तो आराम से we could have scored, but I don't know. I ended up with 305 or 309. I don't remember. But what helped me in the last revision was writing down points like this here. I hope this is visible. I used to write points like this. So please, even if you all are, any points, write down. So that during revision or studying for test series, you don't have to read the entire thing. Just read. See that SAP thing. So I could remember, okay, semilunar patches, sclerenchyma, above AP, above phloem, and high coat, hypodermis is made up of collenchyma cells, HC, like that I used to remember, okay. So let us go to monocotyledonous step. Please write down lysigenous cavity, Lysigenous, lysigenous cavity stores water. Okay. Okay. So monocotyledonous stem. The monocot stem has sclerenchymatous hypodermis. In dicot stem, the hypodermis was, repeat yourself. In dicot stem, the hypodermis was collenchymatous, high coat, HC. In monocot, it is hypodermis is sclerenchymatous. Compare and study. In monocot stem, hypodermis is sclerenchymatous, and a large number of scattered vascular bundles. See, ring vascular bundles characteristic of dicot stem. Monocot stem vascular bundles are scattered, each surrounded by sclerenchymatous bundle sheath. So the vascular bundles are covered by sclerenchymatous bundle sheath in the monocot stem. Large conspicuous parenchymatous ground tissue. Vascular bundles are again. Now tell me, stem conjoined, open or closed? It is monocot. So it is cambium is absent, closed, conjoined and closed. Again, peripheral vascular bundles are large, smaller than centrally located ones. So peripheral vascular bundles are generally smaller than the centrally located ones. So how do I remember this? Peripherally located vascular bundles are generally smaller than the centrally located one. It could come as a true or false statement. Yes or no? How many statements are true? True, right? The question might come. Peripheral vascular bundles in monocotyledonous stem are generally smaller than the centrally located ones. How do I remember? Again, I remember that cow grazing example only. In stem, upper part available above the ground, cows might come and come to graze it. So the vascular bundles present on the periphery is smaller in size, so that much part of it won't goes to cow. Make stories and remember like that. So peripheral vascular bundles are generally smaller than the centrally located ones. Okay. And the phloem parenchyma is absent. That is what we had studied here while studying about phloem parenchyma is absent in monocots. Didn't we study here? If you all were present in the previous live session which I had done in the evening, you would have known this. The phloem parenchyma is absent in the monocots we had discussed. So phloem parenchyma is absent, and water containing cavities are present within the vascular bundles. And I made you right here now. Lysogenous cavity. Those water containing cavities are nothing but the lysogenous cavity are present in the vascular bundles. Okay? So we were live for around 1 hour, and we still have dicot leaf and monocot leaf present and secondary growth present. So it is time almost 11. So guys, try completing this by your own monocotyledonous stem or secondary growth. Otherwise, no problem. Tomorrow we will cover this. Study physics or chemistry. Okay. So daily we are going to do this live session. So today I ended the live session a little early and started also a little late, I guess. No. See, the thing is, I'll have classes till 4 sometimes. Okay, Akash Institute, I'll have classes till 4. So while coming home will be around 5. Then again, while freshening up and all of that will take time. So whatever I will mention in the always in the previous live video session. So if I have to update anything about tomorrow, I will mention in the previous live session video. So because I don't have that community tab option, because I don't have that much subscribers enough, so for that option to enable. So for update, please be watching the previous live video comment session. So guys, tomorrow morning 7 a.m. If you were present that time in the evening session, you all know that morning is going to be a little messy. So I'm going to do mute study with me. That I'm going to mute my microphone and I'm going to study on my own physics or chemistry. You all can study whatever you want. So 7 a.m. live tomorrow. Then evening ka time I will update. In that evening I will be teaching the we are going to study biology NCERT line by line. Okay. So please like this video, and please, if you know anyone who is doing self study or any of your friends who would like to do group study like this together, ask them or send this link to them. And let us meet tomorrow 7 a.m. Mute study with me. You can study whatever you want. I'm going to study whatever I want, because no music and early morning all things is going to be like messy, people moving here and there, vessels and all of that. So yeah guys, it was great studying with you all today, and it's going to be 11. I don't know if you are waking up at 5 tomorrow, sleep or else study. Okay. So I hope we clear needs with flying ranks together, and I hope we do great this time, because 360 out of 360 is very easy in bio. That is what I have learned now from my previous attempt. So thank you guys for watching. It was great being with starting with you all. So tomorrow morning, what time? Tomorrow morning, 7 a.m. Okay. And and evening cut time I will update tomorrow morning only. Hmm? Bye guys. Study, please study. Solve as much as MCQ as you can, and stick to one book. Stick to one book. Do not do my mistake. I used to, like, for this chapter this book, for this chapter that book, and at the end I was like, okay, what should I revise from? Which book should I revise from? That is the worst mistake anyone can do. Just stick to one book. If you have Akash, stick to Akash. Solve MCQs, revise MCQs. Same thing you do. Okay. If you have Alan, stick to Alan. Revise MCQs from that. If you have NCRT, stick to NCRT questions. Revise that only. The exercise questions I'm talking about, not something else. Okay. So, bye guys. If I start talking, I won't stop. You all also have to study. When I have to study, I'm planning to study chemistry now, surface chemistry. Okay, bye.